Hello everyone, Sachin this side from Invent Model. I hope so you guys are well and doing well in your day-to-day life. Let's begin our session. That is, I study a new course that is SQL training. In this course, we learn SQL from beginner to advanced. There is a roadmap that I make for you, right? What I taught in my course. The module first introduce SQL. In this module, we learn about what is database, database management, what are relational database, what are non-relational database, and introduction to SQL, like what is SQL, and then move further to SQL versus no SQL, data types, operator, commands, command like TTL, TQL, DML, TCL, TCL. DDL, data definition language, TQL, data query language, DML, data manipulation language, DCL, data control language, and last one, the TCL, transaction control language. These are the command language in SQL. We further explain it in our video in next sessions. Uh, and the other topics in SQL like tables, views, table versus views, relationships. In next module, we learn about data normalization, entity, ER model, so the process, how the process going, and the types of normalization like 1NF, 2NF, 3NF, VSF, 5NF, 4NF, 5NF. In next module, we started to how to install and set up MySQL in your system. And the other module tells how the database created drop databases. Other. The next module we learn about tables, all the command related to table like create table, drop table, delete table, alter table, and the constraints like primary key constraint, foreign key constraint, composite key, alternate key, and the other constraints. In next module, we learn about SQL DML queries. Select top limit first, last, random, date, and the other select command. Also insert, update, delete. In next module, we learn about where with having order by, group by, limit clauses, SQL operators like non, like and or, like in, not equal, and about joining data. In joining data, we learn about inner join, left join, right join, full join, self join, update join, and we learn about functions in SQL like aggregate function, scalar function, string function, numeric function, date and time function, statistical function, conditional function, and working with JSON, and the other function like ltrim, upper. These functions all are. I have. I think I conclude all the function related to SQL. Basically, I designed this roadmap to cover all the necessary topics of SQL to make SQL developer advanced. In next module, we learn about views, creating views, modifying views, dropping views, indexes, creating indexes, unique indexes, composite indexes, cluster indexes. Now, up to indexes, there is a beginner SQL concepts like it's for the beginners, and the transaction modules we move to the intermediate SQL training. So those who want to learn only basics, they see only indexes videos, and the intermediate started from transactions like atomicity, consistency, isolation labeling, transaction, transaction command like in transaction, commit, rollback, set point. There are these commands used in transaction control. In next module, we learn about data integrity, and security. In data integrity, we learn entity integrity, referential domain. In data security, we learn about authentication, authorization, encryption, auditing, backup, and recovery. In next module, we learn about uh, stored procedures and triggers. Triggers are used in SQL to control the access from the other student to another student. Let's let's suppose about one student wants to access other student data, so it is illegally. So we introduce trigger in SQL that is control the accessibility of the data, that no other one can access data of same person. Next module we learn about performance optimization, like using taxes, optimizing joins, reducing subqueries, selective projection, and the last one is advanced SQL. In advanced SQL module, we learn window function, recursive queries, pivot and pivot operation, common table expression. Okay, I think this is the huge roadmap for the beginner to advanced. So let's jump in the video to don't waste your time. Today we learn about SQL introduction. So let's start our session. So as you see, this is a SQL complete training. Today we introduce SQL. So before introducing SQL, we start some basic concept learning, that is database management. So in today class, we started learning what is what is database management, importance of databases, what are relational databases, and what are non-relational databases, or what is SQL, and history and evolution of SQL. And the last one is SQL versus no SQL. Introduction of databases. So let's start. What is databases? A database is structured collection of data that is stored, managed, and accessed electronically. In simple terms, a database is like a digital filing system where information is organized in such a way that it can be easily retrieved, managed, and updated. And the key points are data. Data is nothing but the information stored in database, like in like your names, your dates, your address, your ID card, your codes, numbers. This all the things are the data. Tables, the primary structure within a database where data is stored in rows and columns, like a spreadsheet. You see Excel spreadsheet in your school time. So, so you see in this spreadsheet like columns and rows, and the data arranged in columns and rows according to the relation. Records. Records means rows in table. Rows in the table, each representing a single item or entity. Entity is customer information, like customer name. Entity is something to denote someone information. Okay, I hope it clear to you. Fields, columns in a table representing a specific attribute or characteristic of the data. Example, name is address field, like your name, your father name, your address, your codes, and these are known as the fields. Uh, I want to clear more about database. So you see in your colleges and in many stores a register or a file system which stored all the interrelated information, like Think of a database is a like a digital version of library. As you see a library in your colleges and schools, so think like a database is a digital version of library, just like books in a library are organized into section, categories, and shelves for easy retrieval. For easy retrieval, data in a database is organized into tables, records, and fields. I hope so database clear to you. And let's talk about the importance of databases. So what the importance of database is storage. Database keeps a lot of information in an organized way, making it easy to store and find when needed. So let's reading this storage. Database store large amount of data in organized way so that it can easily be accessed. As I say recently that database keeps database keeps a lot of information in organized way. Okay. So retrieval is nothing like to use to access data, to use data. So database allow user to quickly find and retrieve specific data. Like specific data, you want to access this data, you want to access Rohan's data. So you access it easily because it is arranged in organized way. So database makes the retrieval of data easier. Management database help manage data by allowing user to add, update, delete, and manipulate data easily while ensuring data integrity and security. So, as I say, that your data is in organized way, so you can easily add, update, and delete what you want to delete in your delete from your databases. Okay, so organized data, they keep data well organized, making it easy to find and use. Ensure accuracy, they help maintain accurate and consistent data through check and rules. It's okay. So supports decision making. They provide valuable insight and reports that help in making informed decision, improve efficiency. They automate, streamline data management tasks, saving time and reducing error. Like improve, like you can access and automate data easily. So improve your efficiency to access data. Enable collaboration. There are multiple user to access. Uh, like we want to access from different person. We want to access it from different person to use and use our data easier and makes it effective way to use. They allow to multiple user to access and work with same data simultaneously. Okay. Types of databases. Relation databases are the data is organized in tables with rows and columns. Relation database are nothing but the data but those organized in rows and columns. Okay. So there are many software, many system, database system available in market, which are the relational databases that are MySQL, PostgreSQL, and etc. Uses SQL for queries and data manipulation. Okay, so we use SQL. SQL is nothing but a programming language that we learn further in our topic, and the same the this training is related to the SQL training. Okay, so SQL is used for queries and data manipulation. Okay, so no SQL databases, nothing but like a non-relational databases that are not dependent on rows and column. Okay, handles unstructured or semi-structured data. Okay, so NoSQL databases are those databases that handle unstructured, means not in the rows and column, or semi-structured. Okay, more flexible schemas than relation database. So there are many software many database management software like MongoDB, Cassandra. Okay, and the other one is distributed databases. It means data is stored across multiple locations but functions as a single databases. Okay, so let's move to a further topic, that is introduction of database management system. A database management system is a software that manages databases by providing a systematic way to store, retrieve, and manipulate data. Okay, so the database management system (DBMs) is a nothing but a software that manages database that, in a systematic way, in an organized way, to store and retrieve data and manipulate data. Okay, data, this is the theoretical part, so you have to read it to clear your basics for SQL development before SQL programming learning language. Okay, okay. Data storage, efficiently store data in structured format. Data retrieval allow user to query and retrieve data using language like SQL. Data integrity ensure data accuracy and consistency. As I said, that data storage, it efficiently store data. It efficiently you can retrieve data. In data integrity, it means data accuracy. You can access accurate data. Okay, data security, you can protect data from others and the unauthorized persons. Transaction management, manage transaction. Okay, so that's why we use database management system. There are many database software system software like MySQL, Oracle, PostgreSQL, MongoDB, Cassandra. Okay, so next topic we learn about what are relation databases. Relation databases, also known as the RDBMS or SQL databases. RDBMS means relation database management system. Relational database management system. Okay, are a way to organize data in tables. This is the way to organize data in tables, rows, and columns. Each row represents a records and each column represents a field in the record. So each row represent a record and each column represent a field. Okay. The key feature of relation database is the use of table to organize data, and this table can be related to each other through keys. Okay. Okay. Some of the most well-known RDMS include like MySQL, PostgreSQL, MariaDB, Microsoft SQL Server, and Oracle databases. Okay. RDMS benefits. Uh, there are the many benefits of RDMS. It organizes data, store data in neat and clean, accurate data, keeps data accurate, easy query, uses SQL to easily search and manage data, reliable transaction, ensure the data changes, okay, handle relationships, links table together to model complex data, backup, allow you to backup and restore data if needed, security, protect your data from unauthorized user. Limitation of RDMS scalability can struggle to handle very large amount. It means you cannot handle large amount of data. Schema changes, modifying the data structure can be difficult and time consuming. Okay. Performance may slow down with your very large or complex query. If you have query, lost. Performance rigid structure, fixed tables and schema can be inflexible. Cost commercial version can be expensive, resources heavy. Okay, unstructured data not ideal for managing unstructured data like text or media. Okay, what is non-relational database? So non-relation database, often called NoSQL database, are designed for flexible data storage and handling large amount of unstructured or semi-structured data. Unlike traditional relation databases that use table and fixed schema, non-relation databases use various models to store. Non-relation database is nothing but a semi-structured data or an unstructured data. We can store many things in non-relation data like videos, images, and the data, informatical data like information of student, employees, and many other things. Okay. Key features: flexible schema. Data can be stored without a fixed structure. Okay, you can store data easily. Scalability, often designed to scale out across many servers, handling large volume of data, high traffic. Okay, variety of models include different types of database such as document stores, store data as document like MongoDB, key value store data as key value pairs, Redis. Redis is our database management software. Okay, column family stores organize data in columns rather than rows. Graph database focus on relationship connection between data points. Benefits: flexible data handling, easily accommodate changes in data structure, high performance, efficient for types of query, large amount of data. Okay, high performance. High performance because we handle large amount of data, scalable, easily scalable. Limitation: consistency, may trade off some data consistency for performance and scalability. It means we can't store consistently data and we can't access a consistently data. Okay, complex query can be less straightforward. So it is a unstructured data, so we have complex queries. Okay, less mature. Some NoSQL data may lack the extensible tool and support available for the relation data. So there are some tools are not available for the non-relational data. Okay, that are available for the relational databases. What is SQL? So we started from. So this is our main topic, SQL. Okay. So structure query language. SQL is nothing but the structure query language is a programming language for storing and processing information in relational databases. A relational databases stores information in tabular form with rows and columns representing a different data attribute, the various relationship between the data values. Structured query language. It means the structured means it is in rows and column. Okay. A relation database stored information in tabular form. Tabular form means it is stored data in tables with rows and column representing different data attributes and the different relationship between the data values. Okay. So it allows you to retrieve data easier, insert data easier, update data easier, delete data, remove records from the database, define structure, create and manage database schemas, include tables and relationships. Okay, so let's talk about the history and evolution of the SQL. In 1970s inception, in 1970, the Dr. Edgar P. Code, a computer scientist, proposed the concept of relation database model, which laid the groundwork for SQL. I hope so you guys understand that the history, the Edgar F. Code scientist who proposed the concept, who takes the concept of relation database model. Okay. In 1974, IBM began developing SQL as part of their System R project to manage the relation databases. So in 1974, IBM started developing SQL to build their System R projects. Okay. Uh, Standardization in 1980s, 1986, SQL was standardized by the American National Standard Institute ANSI and become known as the ANSI SQL. In 1989, the International Organization for Standardization (ISO) also adopted SQL as an international standard. In 1990s, development and enhancement of SQL. 1992, the SQL 92 version was released with new feature. Okay. In 1999, uh, also known as the SQL 3. In 1999, the SQL, also known as the SQL 3, added advanced features like object-oriented capabilities. In 2000, modernization include in 2003, SQL added support for XML and better ways to manage data. In 2006, SQL further improved XML handling and added more features. In 2011, SQL added support for managing historical data, allowing database to track changes over time. A current trend, today SQL continue to grow with new feature for cloud computing, analysis, working with NoSQL databases. Okay, so SQL has constantly evolved to meet the needs of modern data management and technology trends. Okay. SQL versus NoSQL, it means relational databases versus non-relational databases. So SQL, simple, it is a structured language and it show data relationships. It make query language easier, so uses SQL programming language. Consistency, ensure data consistency with the asset properties. Scalability, scales vertically. Okay. NoSQL, non-relational databases, structured, uses flexible schema. It does not depend on structured. It's a half structured language and various models like document, key, value pair graphs. Okay. Data relationship handles unstructured or semi-structured data without complex relationships. Okay. Query language uses different querying methods, often specific to each database types. Consistency may sacrifice some consistency for performance and scalability. Scalability scales horizontally by adding more servers to handle increased load. Okay, thank you. I hope you guys I hope you guys enjoy this session. In this class, we learn about these topics. I hope so you guys understand well all the things. If you have any doubt in query, please comment below. I will reply you as soon as possible. If you guys like this video, please do subscribe our channel and do likes and comments. We will meet in next session so soon. Stay safe and stay healthy. Thank you.